welcome to the studio review for Chapter 12 on objects in math. We are going to practice a number of different ways to work with JavaScript objects. We'll be defining a number of functions and performing different calculations and operations to select a crew for a mission, to perform some calculations related to that mission, and determine how much fuel is required based on the number of crew and all those kinds of things. So we have three parts, and the very first one is going to be in its own file. We'll have three different files, but this is in your JavaScript projects repo in the objects in math/studio directory. So let's look at these one at a time, just look at the instructions. The first one is to randomly select some ID numbers. They're going to give us some ID numbers in an array, and we want to write a function that will select a random entry from that array and return a number. They give us some hints here because they want to make sure that we don't actually accidentally have the same animal be selected more than once. Because we're doing this randomly, it's very possible more than one ID, the same ID could be chosen more than once. And so they give us a tip here. One is that we can look in the array with the includes method to see if that item is already there. So if we're, choosing new entries and putting them in a new array, we can then check and say, hey, do we already have this one? And the second thing is, if we're going to do something 3 times and it's the exact same thing, let's use a loop, right? And a while loop in particular is very appropriate for this situation because we don't know how long it's going to take to get all 3. We may have to try several times if we keep getting duplicates. So let's go ahead and work on that. Come over here to the very first file, objectstudio01.js. Okay, so they want us to code our functions at the top. Then they give us some data to work with, the ID numbers, a bunch of candidate objects. You can see that these all have the same properties: name, species, mass, oxygen used, and astronaut ID. And there's 6 of them here, and they've all been placed into an array so that we can work with the entire array if we need to, and we will. And then down here is where we want to use our functions and perform some of our operations once we've written them. Let's start with the first one, select random entry. This is going to just use the math object to handle the random aspect of things. It also will use the math object for rounding. So I'm going to declare a function with the function keyword and say select random entry and give it an array. We're going to pass an array and say, here's a bunch of numbers. This is what we're going to use it for. We're going to pass it an array of numbers and ask it to return a single number. So the first thing we'll do is get, what is that random index going to be in that for that array? How are we going to decide which one to pick? So I'm just going to call that random index. And then anytime we want to get a random number from in a certain range, like from 0 to 10 or 0 to 100, we want to just multiply the length of the number of options that we want times math.random. So we can start with that and say, let's go to the array and get the length and multiply that times math.random. And remember that random is a method, so we're going to put the parentheses on here to call it. And then it'll return a decimal number to multiply by that length. Now, this makes sense because we have 6 things. If we have 6 things in the array, then we want something between either 0 and 5 or between 1 and 6. Now, here's where it gets interesting. You have a choice if you want to round this because it's going to be a messy decimal number, and that's not going to work as an index, right? So we need to round it. But the decision is, do we round it up? Do we round it down? Do we just round it and maybe it'll go up and maybe it'll go down? But if you're going to be using this as an index for an array, you need it to be 0 indexed, which is why we are going to choose to use math.floor. And we will just round the result that comes back from multiplying the length times the random number that comes back. And then that will actually make it an integer again. It'll make it a whole number, and it ensures that instead of being 1 to 6, it's going to be 0 to 5. And that's exactly what we need in order to use this as an index. So this function is not meant to return the index. It's meant to return the number from whatever array we feed it. And in this case, we're going to be giving it this array. So we actually want one of these numbers to be returned. So we're going to need to return array at random index and go get the element itself. And that's what will be returned from this function when we're ready to use it. Now, keep in mind, this is just a function definition. It can work for any array. We know what we're going to be using it for this, but we will test this down here. So we can go ahead and work on that, because part 2 here tells us we need to call the function 3 times and create a new array that will, store the 3 selected candidates. Okay, so down at the bottom, I'm going to come down here because all the data we need to work with is here. So we're going to have a number of things that we can create here. And it says code your template literal and console log statements. There's actually a lot more that we're going to do than just that. I'm just going to put it all down here at the bottom. Okay, so the first thing is we need an array to hold the selected ID numbers. So we'll say let selected ID numbers. And you might have called this, selected crew. The reason I didn't call it that is because we're not actually storing the crew members themselves from this array. We're just storing the ID numbers. So I wanted to be very specific with my variable name here to, clear up that confusion. We're not storing the animals yet. We're just storing the ID numbers themselves that are chosen. Okay, this is where we can loop through and say, as long as selected items, this new array we created has a length that is less than 3, we will execute this code and, get a random entry. So I'll go get that entry, random entry equals, and then I'll call the function that I wrote, select random entry, and pass it the ID numbers array. Now, if you've forgotten where that comes from, it's up here at the top on line 12. Let ID numbers, and it gives us that array. So this is the data we're actually working with, the real array that we are passing into the function we wrote so that we can get an actual ID number back. So we have the ID number and, you might say, okay, let's push it into here, right? But we also had the requirement that we want to make sure that we don't accidentally push it if it's already been selected. So we need a little bit of logic here. I'm going to say if not selected ID nums includes. So we want the opposite. We're going to look and see if it's already included. And then we want to say if it hasn't been included, then we want to push it. Only if it's not already there. And now we'll put that random entry into selected ID num. So what'll happen is this will keep looping. And as long as we still don't have 3, it's going to pick one and then check and make sure it's not already there. And if it's not already there, it'll push it until we have 3. And then this while loop stops executing. So let's just test this to make sure that it's working. At this point, when the loop is done, we should see that selected ID nums has 3 numbers in it, and they should all be different. That's what we're looking for. I need to change my directory here. So I'm going to go to Objects and Math Studio. Here we go. Okay. So here's our 3 files that we have to work with. I'm going to node Objects Studio 01.js. Okay. And look at that. We've got an array. It has 4 completely different ID numbers that were pulled randomly from this array. Okay, great. So this is the very first part of this. Now we can go over and look at the second part. We want to build an array of crew members that are using, that match up with those ID numbers. So we need a function that takes 2 arrays. We want to have both the array of candidates and also the array of ID numbers that we just selected. So it says, you can use 1 or more loops to check which animals hold those ID numbers and store them in this crew array and then return that array. And then we'll just print a template literal that will tell us who those 3 people are that are going to space. So we'll come back up to the very top of our file here. because this is where they want us to define the second function, and then we'll use it below. Okay, so build crew array is the name. Excuse me. We want to pass in some sort of selected IDs, and we want to pass in candidates. And we want to build a crew. So we're going to start with an empty crew array. And then we'll loop through and say, let's look at each of the candidates that are passed in one at a time. So I'll base this on the length of the array that's passed in for the candidates. And then we're just going to check and see if their ID is one of the ones that's in the selected IDs that have been passed in. So we just say a little logic. We'll say if selected IDs includes, and then we go get the ID number of the candidate. So in order to do that, we need to go to the candidates array and go to index I, whichever candidate we're currently looking at as we loop through that array, and then use dot notation to access the astronaut ID property. If you recall, the way that this works, this array here holds all of these candidate objects. So every single one of these that we see defined here. And each of those objects have all of these properties. If we want to access one of those, we just use dot notation. You could also use bracket notation with quotes, but I'm going to use dot notation. And it'll give us this value. But because we're working on it through this array, we have to use bracket notation just to access the correct candidate at whichever index we're looping through as we're iterating. So we go to that object represented by candidates at index I, and we access its astronaut ID. And that way, every time we loop over, we have a completely different astronaut ID, right? And we're just checking each one as we go through and saying, hey, is this one of the ones that's been selected? And if it has been, then we want to push them into the crew array. And again, we want that entire object that's the element that's stored in the candidates array. So it's going to, make it to where this crew array here is an array of objects as well. Just like this ID numbers that held the items, the numbers, then created, an array here of numbers. We're going to take an array of candidates and create another array that only has 3 of them that match those ID numbers. So the last thing to do here after this loop finishes is return that new crew array from this function. And then it'll be provided for us when we execute the function. So let's come down to the bottom and go ahead and take care of that. So this will be as simple as me saying, okay, I want a variable that I can hold. We'll just call it selected crew. And it will hold this array of just those 3 crew members. So I'll call my build crew array function. I'll pass in, VS Code is telling me right here what's expected, selected IDs and candidates. So first I'll pass in selected ID numbers. And then I'll pass in animals. Because those are the real arrays that we're working with here. This array that we filled up with 3 random numbers and this array that has the candidates. That's what we actually need to work with. So these are the arguments that we pass in to match the parameters. And then the function itself, uses these as local variables to represent all of the data that's been passed in through this, this real data. And then it returns it, since it returns the crew, as you see here on the last line, that means that value is what comes back when JavaScript evaluates this expression right here. And then we store that value right here in the selected crew. Okay. So once we have that, the last thing they wanted us to do was to do a template literal with this little expression here. So we can go ahead and do that. I'm going to console log. And now I need to do a little bit of work on this because we need a template literal. Instead of single quotes, we need backticks. So I'll change those single quotes to backticks. And then here where we have these blanks, we actually need to use placeholder syntax. So I'll do $sign and 2 curly braces. and then same thing here, and then same thing here. And all we need to do here is go to the selected crew and, you know, have each of the three members listed by name. So we can look at these objects. Each of the candidates has a name property. That's the property we want to access, but we need to access it through the selected crew. So I'm going to say selected crew, and the first one we'll do is the crew member that's at index 0, and then access the name property. Then I'll do the same thing here, selected crew at index 1 dot name, and then selected crew at index 2 dot name. And that way we access all three of the crew members that are stored in this, but those are the objects that represent the entire, you know, candidate. And then I just, you know, tack on the with dot notation dot name to get to this value here. So, you know, all of the names that are stored here, Lassie and Jonesy and Paddington, we should see those names actually placed into this template literal when we run it. So let's do that now. Let's see how it worked out. And we'll test both our function and all of this syntax here and these references at the same time. Okay, so it says Paddington, Pete, and Hugs are going to space. So we have evidence now that we successfully built the crew using the ID numbers we had selected and using the animals that were provided for us here. And we were able to access the name from each of those three that were placed in here and produce this nice little sentence here at the end. Okay, that's the end of part 1. Let's go over and look at the next part, orbit calculations. So for this, we have a number of things we want to calculate that are related to the orbit. You know, we are going to need to have a circumference, and we're going to need to figure out how much time does it take to do this, depending on how many orbits we want to complete. And, you know, we'll print something out that kind of, you know, gives those numbers in a sentence. And then later on, we will code another function about calculating the amount of oxygen that's needed. That's a very important thing when you're in space. And we'll use some of the functions we've already written to help us with that, and then, you know, print something else here. And then there will be some bonus missions that we can do at the end. So let's just start right here, though, and just focus on this very first part. Getting the circumference, getting the mission duration. We're going to have to do a little bit of work to do this. Okay, so over in Object Studio 02.js, they have some comments here to kind of guide us on everything we need to code. We need an orbit circumference function, a mission duration function. We need to bring in that select random entry function that we wrote in the other file. We're going to use it this time not to select IDs, but to select candidates directly. And then we're going to also code the oxygen expended function here. So right at the top, if we want to calculate the circumference, you know, they remind us that circumference is 2 times pi times the radius of the orbit. And they want you to assume that the astronauts are going to be at 2,000 kilometers altitude. So I'm going to create a function called orbit circumference. They give us the name, right? So we'll just use that. And then we're going to pass in some kind of an altitude here. And, you know, so we'll start with an altitude of 2,000 when we are working with these numbers and testing it all out, but we eventually are going to make it possible that you could test it with other altitudes. So we'll just pass in the altitude, and then, you know, the orbit around the Earth is not just the altitude. It's actually also includes the radius of the Earth. So I looked this up, and I'm going to create a constant radius of Earth and call that 6371. And that's in kilometers. Okay, so we've got the radius of the Earth. That means our orbit radius, the total radius, is actually the radius of the Earth plus the altitude that's been passed in. however high they are off the surface of the Earth. And then we can just return this, 2 times pi. So we can use the math object to get pi, and then orbit radius. But they do, do they tell us here that they want us to round it? Yes, right here, they tell us to round the circumference to an integer. So that's pretty easy. We can take this entire thing and just use math.round. And then whatever gets calculated there, we'll round it to a whole number. And then that's already been returned. So that's it. That's all we need to calculate that circumference. Okay, that's going to be an important part of the next function. So mission duration needs to take 3 parameters: the number of orbits, the orbit radius, and I think what we really are going to want to do there is the altitude, not the radius. That way we can calculate the radius using the radius of the Earth. So we're going to call that altitude instead. And then the speed. And they want that default altitude to be 2,000 kilometers and the default speed to be 28,000 kilometers per hour. And then we'll calculate how long it takes them to complete however many orbits is passed in. And they remind you that the formula for that is time is equal to distance divided by speed. And then we'll round that answer to 2 decimal places and return that time. And they give us an example here. 5 orbits would take about 2.24 hours. Now that number is going to be based on using 2,000 as the entire orbit. So my number is going to come out a little differently because I'm including, the Earth's radius as part of the total radius. Okay. Let's come over here and code this function. So function, mission duration. All right, they said 3 different parameters, right? The number of orbits, the altitude, which I'm going to default to 2,000. That makes this optional, and 28,000, which makes that optional. So in other words, if you remember with functions, it means it's possible for us to call mission duration and only pass in the number of orbits and not bother with the other 2 parameters because they have default values and we can just let them take those values instead. So the only one that's required is the number of orbits. We'll test it. All right, now we can get the circumference. That's not what I meant to do. We can get the circumference here by calling orbit circumference and passing in whatever the altitude is. Okay, so in this case, it'll pass in that 2,000 unless we've specified something else, and then it'll pass in something else. But it'll pass that in and get this calculation and return that number, and that's what's being stored here in circumference. So now we've got our circumference. Let's calculate the distance. I'm going to take the number of orbits and multiply it times the circumference. How many times are we going around the Earth in orbit? That will tell us what that total distance is. Okay, so to get the time, again, time is equal to distance divided by speed. And speed is one of the things that we have passed in here. Otherwise, we have a default value. So we can calculate that. Time is distance divided by speed, but they tell us that they want us to round to 2 decimal places, right? So the way you have to do that with JavaScript, if you use math.round like we did up here, it's going to give you a whole number every time. So what we can do is use math.round and have it round this, but we can multiply it first by 10 to whatever power of the number of decimal places that you want to do. So if I do 10 squared, because I want 2 decimal places, that's 100, right? You can also think of it as being just the number of zeros that you have here after the 1, that's how many decimal places you're going to get. So first you multiply it by 100, and then you round it, and then the very last thing you do after it's been rounded is divide that 100 back out. And then you should have, whatever the rounded number was, but then to 2 decimal places. Okay. So now that we've done that, they tell us that they want us to print this sentence here. So I'm going to copy that sentence. And there we go. And we're not returning it, we're just printing it right now because we actually want to return the time, but we'll print this before we return the time. So I'll put this in here. Again, I'm going to get rid of these single quotes and put in backticks so we can make this a template literal. And I will change these blanks to placeholder syntax. And I will put in the distance here. The mission will travel distance kilometers around the planet, and it will take time hours to complete. Okay. And then the last thing is to make sure that when we go to get the duration, that this does in fact return the time. Okay. So let's come down and test this out. Okay. This is really just going to be a temporary thing. It's not something we're required to do. So we're going to test both of these functions. We can test orbit circumference. Let's just console log orbit circumference, and let's just pass in, 5,000 as the altitude and see what we get. So I will come here and run Object Studio 02.js, and we get 71,446. What if I change that to 2,000, which is what that default's going to be? We get 52,597. Okay, and keep in mind, these numbers might be different than what you would have gotten if you did not include the radius of the Earth as part of the orbit radius. So that works. We're getting those numbers. So let's try the next one. Let's try mission duration and pass in the number of orbits. Let's say we're going to go for 6 orbits. And I'm going to let it take the default values for the altitude and speed and just pass in the number of orbits. So let's try this out. We should see it gives us the time here, 11.27 hours. And it also gives us the sentence. The mission will travel 315,582 kilometers around the planet, and it will take 11.27 hours to complete. Okay. So we could do that, and we can also test it using the alternate values, right? So let's say it's 6, but let's say our altitude is 3,000 and our speed is maybe 25,000 or something. Let's run that. Okay, so that tells us we have a slightly greater distance because we're further out. We have a higher altitude, and it's going to take 14.13 hours to complete. Okay, so we've got these tested. I think that's pretty good. I'm going to comment those out, and we will focus on what's next. Okay, so now they tell us they want us to take an excursion, and we'll have to decide how much oxygen is it going to take to go and do this on a spacewalk. So we want to write a function called oxygen expended that will take a candidate object as the parameter. So just a single candidate and not the entire array. And then they tell us, we can use the select random entry to, choose which crew member gets to pass. So we can go over to our first file and find this function that we created. And I'm just going to copy it and bring it over here and paste it here. Now, notice this function, the way we wrote it, all it does is pick a random element from array. And so that array can hold anything. Previously, we used it to select a number from this array of numbers. We are now going to use it to select a crew member from this array of crew. So we're actually going to get a whole object here that's represented in this crew array. So I will go ahead and test this real fast just so we can see this at work. And so I'll say console.log, select random entry, and we'll go ahead and pass in crew and just see what we get. Okay, so they selected a random entry. It's either candidate A, C, or E. So we're going to have either, Gordon Shumway or Jonesy or Pete. And you can see that it chose Jonesy, the cat. And so if we run it again, we get a completely different answer because it randomly chose Pete this time. Okay, but at least we know that's working, right? We can actually test this out and say, yep, it's choosing a complete object from that array. And so we have access to that candidate and all of their properties. Okay. So code your oxygen expended function here. This is where we want to start a new function, oxygen expended. And I'm going to pass in a candidate. And again, we're going to need altitude and speed because that, we have to pass those values along to the mission duration because, we have to get the time. So I'm going to do it the same way I did it before, where I say, let's default altitude to 2000 and default speed to 28,000. We can specify it or we can let it take those default values. So we have to get the amount of time that it's going to take first. So we'll say, let the duration, I actually want to call this duration. There we go. And then call the mission duration method that we wrote, the function, and say 3, and then altitude and speed. Whatever the altitude is that was passed in, even if it just takes its default value, it'll pass it along. And then, all of this is satisfied that we need for mission duration. Okay. And then we can calculate the amount of oxygen. Okay. So we need to take a look here at these objects. There's something interesting going on here. Every single one of these candidates has an O2 used property, but it's actually not a static value. It's actually storing a function. This is a method of this object where a function has been defined that allows you to pass in a number of hours, and it'll return the hours times whatever rate that is. And so we can actually call this O2 used and pass in the number of hours for the time that we just calculated, and it'll give us the correct amount of oxygen for each of these candidates who have different rates of oxygen expenditure. So I'll say let oxygen equal candidate.O2 used, and then pass in the duration we just calculated. But they also tell us that they want us to round this to 3 decimal places. So again, I'm going to use math.round. I'm going to multiply this times 1,000 because I need 3 decimal places. Finish off the rounding and then divide back out the 1,000 so that it gives me the decimal places that I need. Okay, now we've got oxygen. That's good. We're almost there. It tells us here that instead of printing a string, it just wants us to return this string. I will copy this and we will paste this in and return this. And I'm going to replace this with backticks like I did before. Use the placeholders here for candidate.name. Whatever the candidate is that was passed in, we're going to just get their name. And then here we can say that the amount of time that's needed, say duration, and the amount of oxygen. Okay, so now we have all 3 of those values placed dynamically into this, and it's being returned, which means we're going to need to, actually print it when we call the function. So we can test that out. We'll come down here and select a candidate. Let selected candidate, and then we'll say select equal, select random entry, and then we'll give it this crew array so it can choose one, just like we did here before, but we were just printing it out. Now we're going to store that candidate that's been selected in this variable so that we can pass it along. And now we'll go ahead and print the return value, that sentence that's coming back from oxygen expended when we pass in that selected candidate. Okay, let's give this a run and see how it turns out. Okay, it says, Gordon Shumway will perform the spacewalk, which will last 5.64 hours and require 0.197 kilograms of oxygen. Okay, so our time has been rounded properly. Our oxygen has been rounded properly. If we run this again, we should see a different result because we'll have a different random member. Whoop, it chose Gordon again. Okay, let's do it again. There we go. Jonesy will perform the spacewalk, which will last 5.64 hours and requires 0.124 kilograms of oxygen. Okay, great. We could test this, certainly test this other ways. We could test it by passing in a different altitude and speed to oxygen expended if we wanted to change those values. I'll leave that up to you to play around with that, but we can definitely see here that this is working the way it's intended. Now for the bonus missions, we are going to take a look at how to conserve oxygen and actually make sure that only the crew member who has the smallest oxygen consumption is the one who does the spacewalk. So we just need to make a couple of extra modifications here. I'm just going to do this by creating a new function. So I'm just going to put bonus mission here. I'm going to create a function called select by oxygen use. Okay, so instead of selecting randomly, we'll select by oxygen use. Otherwise, our calculations can proceed as they did before. So we'll say, you know, let's just start with the first candidate, and then we will compare against that candidate with the rest of them as we loop through. So I'm going to start with candidate at index 1, since we already are going to be comparing to the candidate at index 0. We'll set this up to go all the way through the rest of the array and to increment by 1. And we'll say, okay, the candidate that we want to select is only going to be stored in this variable if we come across one that actually does have lower oxygen. So we need to have that logic in place and say, if the current candidate we're looking at index I, if their oxygen used for, let's say, you know, we'll come up here and see, you know, 1 hour. We just can compare them on the basis of 1 hour. That'll do. And pass in an hour there and say if that's less than the current stored candidate's oxygen that's used for 1 hour, then we will store the new candidate in this variable. Like that. Okay. And we'll just keep going through and only update this variable if we come across another one that has less oxygen than the one that's been stored before. And then when we get to the end, we will return that candidate. Okay. So now we can essentially, you know, reproduce what we did right here, except we're not going to use select random entry. We're going to use select by oxygen use. And we'll pass in the crew to look at the whole crew. And then here, I just need to give it a different name. Let's just call it selected candidate bonus. And so I'll pass in the bonus candidate to the oxygen expended, and we'll see what we get. Let's run it. Okay. Pete will perform the spacewalk, which will last 5.6 hours and require, you know, it looks like Pete got chosen randomly. So, but if we do it again, okay, Gordon Shumway got chosen randomly, but Pete is actually the one who has the smallest amount of oxygen. So, you know, if we choose it by oxygen use, then Pete is always going to be the choice. Okay, great. So that was the first bonus mission. The second one is to calculate how much fuel is required for the launch. We're going to write a number of functions here to accomplish this, and we're going to do it in a new file. So we'll go over to Object Studio 03 and first calculate the mass of the crew by getting the information from, you know, their objects here. Each of them has a mass property, so we can add that up and find out how much they all are going to weigh. And then it tells us here that it takes about 9 to 10 kilograms of rocket fuel to lift every kilogram of mass. So we will use that 9.5 kind of average there to calculate the fuel that we need. So first, let's write the crew mass function just to get the total mass and then round it to the decimal place. We'll come up here, say a function crew mass, pass in an array of crew members, and then say, you know, we'll just, anytime you want to add up, you can just start at 0, right? Go through the entire array, classic for loop to traverse an array, and then just keep adding on whichever candidate we're currently looking at index I. We want to go to their mass property and add that on to this variable that we're tracking, and then we can just return that, return mass. Okay. But they also do tell us that they want it rounded to 1 decimal place. So again, we can use math.round and round it, but to get it to 1 decimal place, we need to multiply it by 10. And then after it's been rounded, we divide that 10 back out, and that'll give us the number we're looking for. Okay. So let's just test this. Down here, we've got a crew that they've provided for us that have 3 of the candidates in it. Let's just, you know, test our function. So I'm going to console log the result from calling crew mass and passing it in the crew. Let's see what we get. So I'm going to node Object Studio 3, and we get 53.2. Okay, what if we were to change up the crew and say candidate A and, you know, candidate E here, maybe slightly different crew, and we add it up and we get 538.8. So I'm going to wager that candidate E is responsible for that at 417 kilograms. So yeah, and candidate A has 90. So yeah, that shot that number up really high. Okay, I'm going to change it back to just what it originally was. It's not really an issue either way. All right, I will just comment that out. That was just a test. So now we need to take that mass, and we're also going to have to take into consideration the mass of the rocket without the crew, plus the food and other supplies. And they tell us that that's 75,000 kilograms. So if we have a fuel required function that will combine the rocket and crew masses and then calculate and return the amount of fuel needed, that will you know, give us that final number. So I'm going to come back up to the top and code fuel required. It told us that the rocket mass was 75,000, and you know, we can just put that in our function. If you also want to, you also could do something like, you know, I'm going to have a constant that I refer to where, you know, I know that amount is always the same. So you could do something like this and say, all right, we've got the rocket mass. That's our 75,000. Now we'll write our, you know, get total mass function, pass in the array for the crew, and then return the mass of the crew when we pass in that crew array, plus the rocket mass. Okay. And that should give us the total mass. Okay, now so far we have not yet actually written fuel required, so we're going to do that. I decided to split things up into multiple functions and have each function do its own job. So I have some helper functions here, but now we can go ahead and do this. We're going to return the get total mass and pass in the array, but we need to multiply it by this factor of 9.5. They told us that it, you know, there's 9.5 kilograms of fuel for every kilogram of mass that's needed. That's how we get the rocket off the ground. So we can return that, and let's come down here and test it. So I'll console log fuel required and pass in the crew. All right, let's run it. And we see 713,000, 5.4. Okay, that's a big number. It's a lot of fuel. But that does the job. Okay. Then they tell us that the launch requires a safety margin. We want to have a little extra fuel. It says, especially if the crew members are cute and fuzzy, of course. So we want an extra 200 kilograms of fuel for each dog or cat on board, but only an extra 100 for any other species. And so we just need to update our method that we already wrote, our function fuel required, to account for that, and then round that final amount of fuel up to the nearest integer, do a little bit of rounding. Okay. So I think what I would like to do is to have another helper function just for getting the surplus before we add it into the fuel required. So let's do that here. Let's say safety surplus, pass in the array. And we will say that we already know that there's a surplus of 100 kilograms for every member of the crew, right? So we can start by giving it a value of 100 times array.length, however many crew members are in there, which of course our test data here has 3 crew members. So that's going to end up multiplying it by 3. But now we can go through and say, okay, but are any of them cats or dogs? Because if they are, then we need to add another 100 because they're actually supposed to be 200 instead of 100. And this may not be the way you chose to do this. You may have chosen to just loop through and do a, if or an else, and either assign 100 or assign 200, and that's totally okay. That's the thing about these problems is there's multiple ways to solve them sometimes, and so you just make a decision. And in this case, I decided to do it this way where I go ahead and give everybody 100, but I'm only going to add 100 more for those that are dogs and cats. So we'll check, we're going to go through the array of crew members and check them one by one. So I'm going to look at the first crew member and each one using index I and just check their species. And if it's cat, or if the current crew member's species is dog, then we're going to take our total surplus here and add another 100. Okay. So then we'll have a total of 200 for any cats or dogs, counting the 100 from here, and we'll return surplus. Okay, so now to add it to the field required, we really just need to add on the safety surplus here. Okay. And call it by passing in that same array. Okay, they do tell us though that they wanted it to be rounded up to the nearest integer. Safety surplus is already an integer, but it doesn't hurt us. It doesn't hurt us to go ahead and include it. So I'm going to say math.round and just include the entire thing. And once it's all added up, we'll just get that to the nearest integer, no decimal places. Okay. So let's test it again. We already have this down here where, yeah, so now it rounds it up, you can see, to 713,405. So we have the safety surplus in there and we have accounted for the rounding. Okay, the last thing we want to do is print. The mission has a launch mass of blank kilograms and requires blank kilograms of fuel. Okay, so this is where we can actually put together everything that we have here into a single sentence. So we'll console log. And I really should just go copy this. Hey, let's do that. Console log. But I will change these from single quotes to backticks. So we have a template literal, and then use my placeholder syntax to replace these blanks. And then I can go get the amounts I need. Okay, so if we want the total mass, I can say get total mass of the crew. And for here, where we want the fuel required, I can say fuel required and pass in the crew. Okay. So now you can see why, it was a good idea for me to go ahead and have a separate mass a function for this, a helper function to get just the mass, because it made it really easy for me to access just that number here and then have the fuel, the total fuel separately. Okay, I'm going to take my extra comments out there, and this is all we really need. Let's run it. All right, the mission has a launch mass of 75,053.2 kilograms and requires 713,405 kilograms of fuel. Okay, that is the end of this studio. I hope this was helpful for you, and I'll see you in the next one.